We are writing the year 2006, and I'm providing network and security consulting to an online gaming company acting mostly in Asia Pacific. I'm called in by the weekends because of strange performance of the servers and all kind of interruptions of the service they are providing to their players. After first investigation, I'm finding out actually that the problem they have is not at all related to their own network, is not at all related to their own servers, and is actually not at all related also to all the traversal network devices that players actually are traversing in order to get to the gaming environment. I see from player perspective very, very big delays, jitters, and in some stages even total impossibility to reach the gaming servers. Understanding that the problem is not on their side, we are calling the co-location provider, actually the environment where the solution is installed, and telling them that there is a problem. They don't know about nothing. They begin to investigate on their side, and very fast actually also understand that everything is external to their border routers, nothing is actually wrong in their network. So on their side, they're doing the next step, and they're calling actually their major ISP that is providing the big pipe that is actually used in order to have the internet traffic getting to the site. When they're talking to the ISP tells them that actually, yeah, they have seen some problems in the network, but they are also not really aware about what's going on, and they tell them, we will call you back, let us just check out what the problem is. After a while, the ISP is actually understanding that they are dealing currently with a highly volumetric attack on one of their other customers. They're contacting the customer and telling them, look, we see here very, very heavy traffic reaching your servers. Can you please take care and can you please assist in troubleshooting and in seeing what's going on? The customer is beginning to try all kinds of things together with the ISP. And actually, after many, many hours of troubleshooting, trial and error, the ISP understands that he will not get probably the solution from the customer and is going actually to the most radical solution. He is actually deciding to null route the entire traffic of this customer, or what we call also in networking black holing, and actually from this moment everything is back up and running for all the others, of course, also for my customer, but actually his customer that was attacked is out of service. I think it took something like 10 hours when the attack was over, and then also his customer was able to return to service. Now what we see here is actually 4 entities, different entities, in 2006 that are all unprepared. First of all, it is my customer. My customer did not have the right tools in order to understand that actually when the service was interrupted or was hardly harmed, it is not related at all to his servers, and it is not related at all to his own network infrastructure. The next thing was that also the co-location provider was totally unprepared. They did not have the tools in order to understand themselves that there is a problem, and furthermore, they took actually an architectural decision that they would rely on one major ISP, meaning that at the same moment when the link or the network of this ISP is saturated, they don't have any alternative, and actually their entire customer base is damaged by the collateral effect of this attack. We're moving on. We're moving on to actually the ISP. And here again, we have somebody who is unprepared. Not at all thinking that there's a possibility, and I remind you, I'm talking about 2006. Nobody actually thinking of that there is a possibility to get highly volumetric attacks. And I must say also that when we're talking about this Asia Pacific, it meant that it is at some island with anyway low bandwidth capabilities. So also this ISP was totally unprepared. And finally, also the customer that was the victim of the attack was also not prepared. So it took this customer also very, very long to understand that they're under attack. And actually, the problem was also that the customer was not able to do anything. And as I mentioned, the final resolving of the problem was having the ISP black hole the entire traffic. I would like to ask you, the audience here, and I don't know how experienced you are with DDoS attacks, but probably you read a lot of news. Do you think that something like this can happen also today, 10 years later? It's an interesting question, but I can tell you that there is only one answer. Yes. Unfortunately, it can happen, and it happens all the time. So I was told also to say some things about me. My name is Jochanan Sommerfeld, as was mentioned. I'm the CEO of Comsep Group, an Israeli company providing security services, security professional services in Israel and abroad, with a subsidiary in UK as well as in Netherlands. I have many years of IT and security experience in all kind of areas. Comsec is providing, as part of the services, a DDoS simulation service that is actually giving customers the possibility to check and to validate their preparedness and readiness for DDoS attacks. What we're doing there, we're actually simulating a real attack on customers while we're working with 3 teams. One team is the red team, a team of experts that is responsible to attack the target system, to attack the customer system. Another team is the white team. It's actually the customer himself that is doing the same thing he would and should do when we have a real attack, and is actually trying to fight us in order to make sure that whatever we're trying to do is not impacting in any way the service that we are testing. Then we have a third team, as I mentioned, the blue team. This is actually sitting next to the customer, is responsible for the communication between the white team and the red team, because you may understand that although many customers are sometimes in a confident level that there is no chance that we can bring them down, it works always. And then actually we need the possibility to push the button and to stop the attack immediately, because we're dealing with real services. And second, what is also very, very important is to provide the transparency of the impact to the management that is ordering the attacks, so that we make sure that when we are attacking, we get full transparency of the results. And this is, of course, very, very important in order to give the possibility to remediate or mitigate or correct the weaknesses that we find in the system. Sorry. Furthermore, before joining Comsec, I was for more than 7 years the Chief Information Officer and Chief Security Officer of Playtech, the biggest online gaming platform provider in the world. And there I had the opportunity to deal with a lot of very aggressive DDoS attacks, very volumetric DDoS attacks. I've seen DDoS attacks of 250 gigs, And what I'm trying to do in this presentation is actually to bring together both things. One is my experience of many, many years with dealing with DDoS attacks as a defender, and this is probably what most of you, I hope at least, are doing. On the other hand, due to the fact that we are running a DDoS simulation in ComSec, I have also the possibility that I integrated in this presentation all kind of experiences that I got from our DDoS expert team that is part of those testing or simulation exercises, so that actually we're bringing two perspectives together, one of the defender that we're all used to, and actually also the one of the attacker. I know that for the technical audience here, it is always very, very boring to see numbers, so I will just really very, very shortly talk about some trends in DDoS. I think it's important to mention them. And then I will really immediately go to DDoS case studies, or actually exercises, so that you will see common practices that are used in order to mitigate DDoS attacks. And I'm emphasizing common practices because common practices are not always best practices. And this is very, very important to understand. Next, all part of those cases, I will point on all kind of technology limitations that we have, okay, that are in many, many cases unknown and important when you are focusing on DDoS mitigation or when you're planning to deploy something. And last but not least, I would like also to share with you a DDoS mitigation lifecycle that assists to avoid many, many problems and mistakes that I have personally done and many, many people in the industry are doing. So let me introduce to you our DDoS target. I decided to use a virtual company name that is target. It has nothing to do with the target that was attacked 2 years ago. So it's really important that you don't connect it to target. It's not the real target, but I think there is no better name for a target company than target. So you see here actually a variant. I'm sorry also for the quality of the layout. It seems that the streamer here is not at the right resolution, so it looks very bad, but I hope that you can at least understand the idea. So we have here really an ISP backbone. We have a very, very classical, at the moment, not put any redundancy in network of some online company that is called Target. Could be anything. It could be e-commerce, banking, etc. It has a router, a border router. It has a load balancer. It has a firewall. In this case, also including an IPS. No, I think can you hear me? Okay. Also including an IPS. Furthermore, we have front-end servers, and we have also, of course, back-end servers, and I thought that it is not needed to go into more details about the architecture. Now, as I mentioned, I would like just to mention some numbers that you are aware what's going on in the world of DDoS. Things that are currently a comparison of Prolexic, which is today part of Akamai, that is mentioning that we have a 133% increase in DDoS attacks in the world over the last year. The amazing thing is that we see a clear dominance of layer 3 and layer 4 attacks. And here I would like also explain where it comes from. It comes mainly because also the attackers are acting under economical assumptions. And what it means is just that it is so easy to attack successfully customers or victims with layer 3, layer 4 attacks that there is actually no need to go further. And if there is no need to go further and there is no need for more investment, they will not do that. We see an increase in the average attack duration. So if you see, if last year it was about 17 hours, we are today already about 20 hours. or almost 21 hours. And this is something that is really the average. So I've seen attacks that are going on about months. We see actually that there is a decrease in the peak bandwidth. Okay, so if you look this year, you see that the peak bandwidth is not something that we have seen in the last year. You have seen all the time an increase. It's not at the moment increasing. But what we see is definitely that the volumetric attacks over 100 gig are doubled. Okay, so it's double than what we had last year. And here just, last slide, I don't know even if you can read it, but what it says in general is that the most attacked industry is the gaming industry. This is where I also got all my experience. And you see, of course, also gaming technology, banking technology, also industries that are very, very actively attacked by DDoS attacks. Okay. So now what I would like to do in the next half an hour is to give you an idea about real and simulated DDoS attacks on target. Again, mentioning it's not the real target. It is at the moment just for the presentation, the company that I call Target. What I will try to show in these presentations or in these cases is really also that many of the solutions, of the concepts that are implemented and are actually sold as bulletproof are not the medicine against DDoS and are not always doing the job. Okay, so here what you see actually on the layout is Target, our customer, and we see currently that we have several botnets coming from various autonomous systems attacking our target company. What we see here currently, or what we like to talk about in the first real attack, is actually a layer 3 DDoS attack of volumetric nature. In this case, you can see here that targets still do not have any specific DDoS mitigation capability implemented in the network. They have all the standard things we know, but there is nothing related to DDoS. And actually, they are currently attacked. Target's security team understands that something is going on and is actually trying the first thing, something that naturally all of us would do. When you are attacked, you're looking who is attacking you. So what they're doing at first stage, they are actually beginning to search for IP addresses that are coming out as not valid connections and are beginning to block them with access lists on the routers. Very fast, they understand actually that the attack is ramping up. It begins to be too strong. The routers are not able to deal with it. They are contacting their ISP and telling them, look, you have to assist us. Please block IP addresses so that they will not reach our data center. And the ISP is doing exactly the same, is beginning to block big IP address spaces that are provided by Target, and is actually trying to get control of the attack. The problem is that what we are dealing here with the high volumetric attack is actually UDP packets, maybe spoofed SWIN packets, and actually the amount of IP addresses that we are blocking is so big that what happens actually that they are maybe having a bit less stress on the servers, but actually also clients, real clients, are not reaching their site. So actually, this is not helping very much. Then the ISP tells them, you know what? I have a very, very good idea. What we could do actually is we could begin to work with some kind of access rates. So let us limit the amount of new connection setups, and let us anyhow limit the amount of concurrent connections to the site. But again, the problem is that when you're doing something like this, and for sure when we're talking about a volumetric attack, it will not assist you a lot. And this is exactly what happened, because you are not only disconnecting the evil that is trying to attack you, also legitimate customers. So at the end of the day, what happens here is that they're ending up in a situation where the ISP is giving them one additional advice and tells them, look, maybe you can tell me exactly which services you are running on your environment. What actually came out is the target was attacked by all kind of UDP ports, all kind of TCP ports. None of them were related to any service running on their site. So actually the last advice they got from the ISP is, let us block all those ports that we don't need. They blocked it also on ISP routers. They blocked it also on target border routers. And from this moment, actually the attack was over and everything returned to normal. What we see in this specific attack is clearly that if they would have discussed before the ports and would have configured them properly, probably this specific attack, as it seemed to be an opportunistic attack and not a targeted one, would not do any damage to them. So from my perspective, just as a side comment at the moment, is that you should always, even though you don't have yet in your organizations any kind of specific DDoS mitigation device implemented, you should always study your network and the protocols that you're using very well and make sure that you are already filtering things like wrong ports at the border. Because you know that when you look at the chain from the border router into your organization, as later you're doing this filtering, as more expensive it is, because the parsers are working significantly harder. So doing something like this on router level is very easy, and if you have even the opportunity to do it together with your ISP, then he can do it even already on his side, and it will at all not saturate your link, which is definitely a very, very good thing to do. But again, all of us, you know, we are attacked. We didn't operate very well, so we are asking ourselves, what is the next thing? And of course, Target was sitting with their experts and was sitting with their ISP, and they got the solution. We need scrubbing. Scrubbing devices usually deliver the protection by diverting the traffic through the scrubbing center. What does it mean? It means that normally when the traffic goes to your service, to your servers, and you understand that you're under attack, what you're doing actually, you are normally connected with GRE tunnels or any kind of specific tunnels that allows you to be directly connected with the scrubbing center. And with BGP advertisements, you are making sure that the specific address spaces related to your service are routed through the scrubbing center. That means that you need, first of all, technically, you need to be aware of the fact that your traffic is only seen by the scrubbing center unidirectional. So only the ingress traffic to your site is going through the scrubbing center and not the returning traffic. So have a look here. You see that actually as well the attacking traffic from the botnets and the real user traffic is actually at the same moment when you decided and you did the BGP updates is traveling through the scrubbing device. What happens now here at this stage is that the scrubbing device is throwing away bad traffic and is actually sending over the good traffic to your site. So the entire idea is actually to have a clean pipe from the scrubbing center to the site. I would like to take here another real attack that I have seen, where Target, again, and again, you understand Target, it could be many companies, it's not always the same company. Target was again attacked by a volumetric attack, this time 70 gig, and as was promised by the experts, by the ISP, by the scrubbing service provider, they did a real good job, and they were able to bring down the attack of 70 gig to 120 megabit per second. An amazing job. But what was not discussed with Target and told them that even though all those scrubbing service providers and all those scrubbing device vendors telling you that when you are using them, you get a clean pipe to the data center, it is not entirely clean. It is actually still in specific granularities containing bad traffic. And this bad traffic of 120 megabit per second was too much for the infrastructure. So the old routers that they did not replace were crashing again. So look what a nice thing, right? We have an amazing service that is able to cut down 70 gigs to 128 mega, and still we are suffering. Another thing that they did not consider is they were actually not taking enough bandwidth commitment from the ISP. So what they did actually, they were only considering bandwidth related to their peak traffic that is real traffic. What you need, of course, if you would like to tackle with such an attack, you need to have some spares. So there were no spares. And the problem was that also the network itself, not only the routers, were saturated. So what we have here is a very problematic situation where we see that although we have a very efficient solution for scrubbing, we are not able to take care of the attack. Now I would like to come to simulation attack. Something we did in our company. What we did actually, we attacked the customer with a very simple attack, a SYN attack. But what we did actually was that we were doing it in a highly distributed manner, meaning that actually the amount of concurrent or the connection rate of the SYN attack from specific IP addresses was very low. But this very low was consuming altogether, or aggregating altogether to quite a nice amount that was a joke for the scrubbing center, okay? But what was the problem? The problem was that actually the scrubbing center, as I mentioned, sees only one direction of the traffic. Now, as the traffic was coming from so many IP addresses, they were not considering any of those things as an attack. What is the common solution that you all know for years on firewalls, on load balancers, is actually SYN cookies, right? So what you're doing actually when you have a feeling that something is going wrong, you are actually using a proxy for delayed binding, and you're working with SYN cookies in order to let the other side respond, and then you know if it's a real client trying to access you or it is just a SYN attack. But the problem is that in order to do that, you need to see traffic in both directions. You need actually a proxy. And as mentioned, this device here, the scrubbing device, does not see the returning traffic. And therefore, this was not a possibility or a capability that could be provided. So here again, we had a problem that we were not able, although we have a great device in place, to mitigate this attack. I would like at this stage also to mention that those scrubbing device vendors understand, of course, the limitations, and they thought about all kinds of solutions. And there are solutions, but unfortunately, none of them are working perfect. One of the solutions is that they're actually running resets. The problem is that when you are running resets, you can get very, very serious problems with protocols that are time sensitive or services that are time sensitive. For example, in the industry that I was before, if you have a big poker network, many, many players playing together, and you just disconnect them, you may understand what it means. It's a big problem. Another thing they came up with is actually HTTP redirects. So you are coming with HTTP and I'm redirecting you, and this redirection gives me actually the possibility to validate if the attacker is, or if the source IP that is coming to me is an attacker or it is a real client. But this is of course also self-explaining, only working with HTTP. It's even not working with HTTPS. So when you're an SSL, this is not a good solution. So they came out with other things like out-of-sequence solutions like ACK. So an out-of-sequence ACK, and if I have a real client on the other side, he will actually reinitiate. But as you probably know, many of the network security devices are actually blocking those things because they are actually following the states, and when they understand that something, is not in order, they just block the packet and it's not going through. So what I'm trying to say is that even though you have a very expansive, very good solution in place, it is doing a lot of good things, but it's not good enough. Another very, very important thing is to understand is also amplification attacks. In amplification attacks, we have the same problem that we are actually using open servers, DNS, NTP, etc. And again, we don't see the returning traffic at those scrubbing devices, and therefore it is also very, very problematic for us to take care. I'm in time? I am, right? Okay. So after having all this trouble, after being already tired that we spent in Target a lot of money in technologies, we were sitting again, or the customer was sitting again with all the experts and got the next very, very important tip. You have to go with an inline appliance. Inline appliance that you will install on site, and here you will be able to overcome the problems that you've seen before. So let me just say what it means. Inline, in our case, means actually that we're still, of course, using the scrubbing device, but actually when traffic is entering our site, it is going through this device that is now seeing both directions of the traffic and is actually also taking care and deleting attacking service. But we should be aware that also those inline devices have their limitations. And I would like to show now, attack scenario 5, where actually you see here again the same botnets, and therefore it's always the same layout. Nothing is changing, it's just maybe changing on protocol level. And here again is attack relatively massive, and again very, very good mitigated on the scrubbing device. Let me just see that. Very, very good mitigated on the scrubbing device. But what happens actually that the inline device that was now responsible to take care of all those things that the scrubbing cannot take care was not configured very well. And it did not do the job. So what Target decided with their network engineers, okay, we have to connect to this inline appliance, okay, that is installed somewhere remotely in a data center, in order to adjust the configuration and to make sure that nothing wrong gets through. Surprise, surprise. Again, investing a lot of money in good technologies, but not understanding that it is also very, very important to design the network in a proper way. What happened here is that Target did not take care that the management was outbound, and instead it was inbound. It was actually needing to access the device through the same pipe that was currently saturated with the attack. So Target was not able to connect to the device and to do the adjustments and configuration in order to take control. So here you see they had no other choice than waiting until the attack went over, and then they could connect finally to the device and to make the configuration. So here again, very, very important for all of you to understand. Good technologies is very important, but you have to make sure that you are implementing and deploying it in the network in the right manner, and make sure that you, whatever happens, can access this device. So what Target did was again sitting with the experts and of course understood that what they have to do is to connect to the device through the private MPLS network of their data center provider. You may understand that when you are under a DDoS attack, then the part that is really problematic to access and to use is the public part of the internet, but the internal MPLS network of the provider is not at all impacted. And therefore, at the same moment when you take, for example, this as a solution, and there are also some other possibilities, then you make sure that no matter what happens, you can access all internal devices and make your adjustments. And we have to understand that exactly in such a warfare, the possibility to be dynamic when you are under attack and being able to change things is super, super critical. Another good example that is, again, also pointing on architecture. So again, we decided to attack Target. Now they are already very, very sure that they know what they are doing. So we made sure that we're going through the MPLS network in order to reach the device. Everything is settled perfectly. And we are asked to attack a marketing website. We're doing it again with a very, very simple attack. And it takes us exactly 2 minutes, and the site is down. And not the site only is down, there are all other problems happening in the network. So we are, with the white team and with the blue team, we're checking out what happened. It's very simple. Because of PCI requirements, they were required to have log reviews on daily basis for this front-end server, as for the other servers where actually payment information was flowing through. As most of you, of course, don't have the possibility to review logs on daily basis, all of them are going to the same solution, and they were actually using the SIEM, setting up alarms, which is definitely considered by PCI DSS as a compensative control for daily log reviews. But what happened here is that they did it for this poor front-end server, and it was just, filling up the SIEM, and they were blind. So nothing worked anymore. Of course, the server was interrupted itself, but also the security team was not able to see anything that is going on in terms of security in the company. Now, you may understand that there are many, many DDoS attacks today that are actually smoke in order to have other attacks running next to it. And here exactly an example. Security team totally blind, okay? And by the way, I've seen also situations, today we are in the age of big data. We like to collect everything. And here also you come very easily to a point where you might have too aggressive data collection that is actually hurting infrastructures and making you trouble, not specifically on the server that is attacked, but on other things that are influenced or collocated. Next, also in this situation, what we did, we said, okay, let's try an amplification attack. And what we did actually, we did a file, they had a file server, we were attacking the file server with a 1K request. We were not required to do too many requests, and therefore also the inline device was not recognizing us as any kind of an attack. And what happened actually that we were able to fill up the bandwidth capacity with the returning traffic, because it was a 1K request bringing back a several megabytes of file for each of those requests. So this is also very, very important to understand, that you might be in configuration in a situation that you are reducing the amount of connections, you're reducing the amount of concurrent setups, but at the end of the day it might be amplified with the request return, and therefore it's also very, very important to consider those things. Okay, I see that I'm very, very close to the end of the timing, so I would like just to mention some other things that are also very, very important to consider. In many, many situations, customers are using CDN solutions for DDoS mitigation. Please be aware that this is a very effective solution, but it might be very problematic when you're using dynamic content. So it will work very, very well for static content, highly distributed. It's a big problem for dynamic content. And I would like also maybe touch one thing that I was even asked yesterday when I was meeting with the customer. Many, many customers are asking about how effective is the usage of geolocation. So here I can tell you also that we did a simulation for target again, and we were attacking them from all over the world. They were understanding that the servers that they are providing to customers was only relevant for a specific geographical region. So what they did was very, very simple. They were just blocking everything that was not coming from this region. It, of course, blocked us for a moment, but we understood what they're doing, the same as probably each experienced attacker would understand. And then what we did, we were just using our botnet that was in the same region, and we're again able to bring them down and to attack the servers without any problem. So let me now just round up. If you look at the scenarios that we have gone through, you see at all of them actually very, very similar things. I think the most important is that customers are not prepared. Customers, like probably it's human nature, think that it will happen to others and it will never happen to us. And they are not prepared accordingly. And therefore, what is, from my perspective, the most important thing before the technologies that you're implementing is really make sure that you are thinking about how to set up your network. You are making sure that you're creating the tools, because what you have seen as well is many, many situations where people were not able to detect that they're under attack, and they were wasting a lot of time with all kinds of troubleshooting instead of taking care of the specific attack. It is very, very important to make sure that people are trained. Okay, it requires incident response like any other security incident. And this is also something that is somehow, in many, many cases, not done. So you are dealing very well with other security attacks, but when it comes to DDoS, we were not really thinking about it. And I'm definitely asking each and every one of you to do testing. So when you can, use simulation. Sometimes you can do it yourself. I would definitely not recommend to try to get any attacks from the darknet. So if you need, then you should really contact companies that are doing that. And what is also very, very helpful is to collect intelligence in order to know in advance what is happening in the industry and what might happen to you specifically. Okay, I think because of the time, I will not go through the entire cycle here. We'll let you just to read through it, but I will just mention identification. Super, super important, making sure that you have the capability to identify and to detect that you are under attack. Traceback, although it is not always possible because it's very often spoofed, etc., etc. If you're able to trace back, it's definitely something that can assist us a lot. If we are understanding the origins, we can work with all kinds of blocking techniques. Understand the impact. It's sometimes, you know, we are panicking where we don't need, and sometimes we don't where we should. I think that what is most important, and many, many times not done when it comes to DDoS, is post-mortem. People are so happy that the attack is over, so happy that the CEO and the board is not troubling them anymore, that they're not doing the most important thing. Actually talking with their teams again about the attack, talking about what went wrong and what can we do better in order to reduce the impact. I think that I would like really to finish with the same sentence that was at the beginning of the presentation. DDoS protection technology is far from being install and forget. So whatever you're doing, whatever technologies you implement, don't think that you put it in place and you're done. It's a warfare. It's something that requires the right architecture. It's something that requires attention all the time, and it's something that needs to be dynamic because the world outside that is trying to attack us is as well dynamic. And what I'm saying all the time, the only thing that is relevant in security, that is constant in security, is the change. Thank you very much, and I will be happy to answer questions.